Alright, so today's video is about constant acceleration equations. So let's get started. So we're going to talk about the list of variables that you're going to use in these constant acceleration equations first, and then we're going to talk about the actual equations themselves. So first is our list of variables. There's 6 of them. First is the initial distance, which is the location of the object at the beginning of the event that you're observing. This will usually be 0 if you're thinking of this as how far the object has traveled. And then there's the final distance, which is the location of the object at the end of the event. And if you're thinking of the initial distance as 0 and how far it's traveled, then this will be the total distance traveled throughout that event. Then next we have our initial velocity, which is the speed of the object at the beginning of the event. And then similarly, final velocity is speed of the object at the end of the event. Next is the time, which is the amount of time that passed between the beginning and the ending of the event in question. And then lastly is the acceleration, or the rate of how much speed the object is gaining. So now that we know those, and you saw those symbols there, we can actually show the list of equations here. There's 5 of them, and the equation that you want to use will depend on what values you already know and the value you're looking for. So you'll notice that none of these have all 6 values in them. In fact, the first one only has 4 of them in it, but most of them just have 5. So when we're solving problems, that'll be something important to note. So some tips is that when you're solving a problem, start out writing the list of variables and fill it in with what you know, and noting which missing value or values you're looking for. And from there, you're going to want to look for the equation that uses variables whose values you know and or are looking for. So that's kind of the strategy for how to take these problems on. And a few small tips is that when you see something in the problem that says something like starting from rest, then that should instantly tell you that your initial velocity will be 0. And then next, if there's like something falling, at least on Earth, which a lot of these examples will tend to use because we live on Earth, then the acceleration in that case will be 9.8 meters per second squared, which is the value of gravity here on Earth. And then an important note is to mind the units. I haven't mentioned the units yet. I just kind of want to talk about the concept, but for the purposes of these practice problems coming up, we're going to try to make sure our distances are all in meters, our velocities are in meters per second, our time is in seconds, and our acceleration will be in meters per second squared, because that's usually what you'd see in a lot of these problems. And if you don't have it consistent like this, then the equations don't really work. So yeah. So that brings us on to our 2 practice problems we have here. So our first one, a car starts from rest and reaches a speed of 60 miles per hour in 5 seconds. What is the car's acceleration? And you'll notice you're given a speed in miles per hour. You'll have to convert that to meters per second, which if you need to look it up how to do that, then you can. But I'll also show that in the solution. And then number 2 is a ball being held by someone is released and falls 60 meters. What speed is it falling right as it hits the ground? And you're going to answer this in meters per second. So stop here, and if you want to try these yourself, because I'm going to start going over the solutions to these here in a second. So starting out with our first solution, so the first thing you're going to want to do in this particular problem is to convert that 60 miles per hour to meters per second. So to do that, we have write it out like this. First, we're going to cancel out the mile. there's about 1,600 meters in a mile. So put the 1,600 meters on top and put the mile on bottom, and that'll cancel out the mile. So now we have meters per hour. And then to get rid of that hour and turn it into seconds, there's 3,600 seconds in an hour. So divide the current value with that 3,600 seconds, and then once you do all that, you're going to be left with about 26.67 meters per second. So now that we know our velocity, we can do our list of known values and what we're looking for. So our initial velocity is, since it starts from rest, that means it's our initial velocity was 0. And we just found our value of velocity in meters per second. And the time was also given to us as 5 seconds. So, and we're looking for the acceleration. So we can disregard the distance variables. And then now we can pick an equation where our only unknown is the acceleration. So the first equation, this one, is the best fit for that. And now you're going to remove the values that equal 0, which would be the initial velocity in this case, and then you get the acceleration by itself on one side of the equation. So the initial velocity is 0, and from that point you just divide both the time from both sides, and that's going to leave you with the acceleration is equal to the final velocity divided by the time. So now with that we can plug in our actual values and solve it. So 26.67 meters per second divided by 5 seconds gets us about 5.33 meters per second squared as our acceleration. So that's the answer to this first problem. Now we're going to the second one. So on the second one, we don't have anything to convert, so we can go straight to our list of known values and what we were looking for. So the initial distance and initial velocity are both 0. We were given that the ball drops 60 meters, and then the acceleration is, since it's something being dropped, like I said, and I guess I didn't say it in the problem, but it's assumed that it's on Earth. The value of the acceleration would be the value of gravity, which is 9.8 meters per second squared. And then we're looking for the final velocity. So we're going to pick an equation where the only unknown is final velocity. So we're going to pick an equation that doesn't have time in it. And the only one that fits that is this one. V squared equals the initial velocity squared plus 2 times acceleration times the change in distance. So yeah, we can simplify this since both our initial distance and velocity equals 0. And we need to get velocity by itself on one side, which the only thing we need to do here is square root both sides, which is what we can see here. Velocity will equal the square root of 2 times the acceleration times the distance traveled. Now we can just plug it in and solve. Yeah, 2 times 9.8 times 60, and then square rooted all that is going to get us about 34.293 meters per second as our final velocity. So yeah, hopefully that all made sense. If you have any questions or feedback, leave them in the comments. I'll see y'all later.